Welcome to this predicted paper from onmaths. This paper represents the best guess for the upcoming exams. Please use this paper in addition to your other revision. You can complete a unique version of this paper by going to our onmaths site. onmaths is full of free content to help you prepare for your exams, such as topic-based papers, demon questions and mini mocks. If you like what we do, please consider subscribing. For us to create the largest number, we need to pick the biggest digits for the start of the number. So the biggest digit is 7, then 6, then 4, then 3. But the question says it wants the largest even number, so we need to just swap the last two around to make sure that it is even. So our answer is 7,634. For this question, it's really important that we understand what the words sum and product mean. Now, sum just means add, and product just means times. So we're going to start by adding the 5 and the 4. So that will equal 9. And then what we're going to do is find the product of 9 and 7. So we're going to multiply them together. 9 times 7, which is 63. So our answer is 63. Looking at this line, what do you notice about all the coordinates? Any coordinate along this line, the x coordinates are going to change, but the y coordinates will always be 3. So the equation of the line is y equals 3. First thing I'm going to do is just copy down this diagram to the side here, just so we can kind of see what's going on a little bit more. Just extend this a bit. Okay, so the first thing I'm going to do is convert the measurements here into centimetres. So we've got 3,000, 5,000, 1,000, and we've got 6,000. And then I'm going to look at this scale here. Now this says that 1,000 in real life is 1 on our scale drawing. So this is just going to be 3 centimetres divided by 1,000. This is going to be 5 centimetres, 1 centimetre, and 6 centimetres. And then let's draw the diagram. So I'll do 3 centimetres. This is going to be 5, and so it's 1, 2, 3, 4, 5. Got 1 across here. And I'm going to do the left hand one, so 6 down. 1, 2, 3, 4, 5, 6, and then just join them up as it shows on the diagram. And there we go. The angles in the triangle add up to 180, so I'm going to take away the angles that we know, which is this 63 and this 72, from 180, and when I do that I get the answer of 45. So my answer is 45 degrees. So what we need to do is find out where the graph is at its highest, and so it's highest here. And so if we go down from there, we find out what year it is. Well, these years seem to be going up in 1, so that's 1950, 1951, 1952. So the answer would be 1952. So firstly, we're going to work out what the percentage increases are as a multiplier. So we start off with 100%. Jane has a 1.2% interest pay rise, sorry, and so that would be 101.2%, and we divide that by 100 to make it a multiplier. The multiplier is 1.012, so we get the 20,000 times it by 1.012, and that gives us 240. Next we do the same for Lenny, so that is Jane, and so let's do Lenny, and so that's 100% plus the 1.5%. will be 101.5%. Make that a multiplier, 101.5%. We divide that by 100, which give us 1.015. And then finally what we do is we get the 17,000 times it by the multiplier. And when we do that, we get 255. So Lenny has 255, Jane has 240. So it says which of the employees has a larger pay increase and by how much. So the answer will be Lenny, and it's by £15 because that's the difference between these. To find the area of a parallelogram, we use a simple formula, which is the area is the base times the height. Now the base and the height must hit each other at 90 degrees. So this length here is not counted as the height because it doesn't hit the base, which is here, at 90 degrees. The height is this length here, and the base is either this length here or the length at the top. It doesn't matter because they both hit the height at 90 degrees. So we're going to do the base, which is 11, times the height, which is 3, and that gives us 33. Now both of the base and the height are in centimetres, therefore the area will be centimetres squared, 33 centimetres squared. So we know that the mean is the sum of numbers over the amount. But in this question, we're actually given what the mean is. We're given that that is 29. We're also given the fact that there are 4 cards, so we're given the amount. So what we can do is just get our lines in and solve this. So what we're going to do is just times both sides by 4. So we're going to do 29 times 4, which is 116. And so we know that the sum of the numbers will be 116. So all we need to do is to find the 4th card, is get that 116 and just take away the numbers that we know. And when we do that, we get the answer 26. Now you can easily check this by adding up 37, 26, 27 and 26 again, and then dividing it by 4, and you will get 29. We've got to first of all identify whose graph is whose. So looking at the green one hits the y-axis at 6, and it says here that Taxico charges an initial £6 fee, which would tally that up, and AB Taxi says that its initial charge is 12, which is on our graph there. So AB Taxi is blue and Taxico is green. Now it says which is the cheapest to travel 20 miles. So what we're going to do is go to 20 and draw a line up from 20. You can see that the blue line is actually lower than the green line. Okay, it's cheaper. So the blue line is cheaper, and the blue line is owned by AB Taxi. So the first thing we're going to do is write this as a ratio between the fractions. So we're going to have green to black. Now it says that a quarter of the counters are black, and therefore the remaining counters will be green. So if a quarter are black, that leaves 3/4 to be green. And what we can do here is on both sides of the ratio, what I'm going to do is just times it by 4. So I'm just going to times 4 both sides. So 3 divided by 4 times 4, because over 4 just means divided by 4. So 3 divided by 4 times by 4 just gets rid of the fraction. And 1 divided by 4 times 4 is just going to be 1. Now this might surprise some people because they will probably think it's a ratio of 4 to 1. But we can show here that it's a ratio of 3 to 1. So adjacent angles in a parallelogram add up to 180, and the reason for that is that we've got a set of parallel lines here, and both of these angles are within that set of parallel sides. So they're actually co-interior, interior, or allied angles, whichever you choose to call them. And so we know that they're going to add up to 180. So we're going to do 180, take away the 61 we already have there, which is 119. So our answer is 119 degrees. So with a stem leaf diagram, the numbers in the middle often represent tens. They could be units. So we look at the key first of all, and we see that 3 line 9 means 93. So the numbers in the middle are going to represent 10. So this is a 90. Now we're looking for English, so this will be 92. So our first number will be 92. Then this will be 10 tens and a 4. So it would be 104. 11 tens and 1. So 111, and then 11 tens and 2. So to find the median, we go cross out the biggest and smallest until we're left with 1 or 2 in the middle. Here we're left with 2. So what we're going to do is we're just going to add the 104 to the 111, and we're just going to divide that by 2. So when we do that, we get 107.5 or 0.5. So our answer is 107.5. To answer this question, we need to cut this shape into 2 shapes. So we're going to draw a line across here, and we're going to cut it into a rectangle and a triangle. Now we need to first of all label the parts of the triangle. So the length or the width of the triangle, the base, will be the same as the base at the bottom, so that will be 20 centimeters. And we need to find the height, which is this length here, which is 90 degrees to the base. And to find that, what we can look at is the fact that the total height of the whole thing is 13, and the height of the bit we don't want is 11. So what's left over? Well, 2 centimeters will be left over, so the height will be 2 centimeters of the triangle. So let's work out the area of the triangle first. Which is going to be half times base times height. Half times the base, which is 20, times the height, which is 2, will just give us 20. Now let's work out the area of the rectangle. And that's just going to be the width times the length. Width is 20. The length is 11, so that would be 220. Then to work out the total area of the whole thing, we're just going to add those together. So 220 plus 20, which is 240. The units are all in centimeters, and so the area units will be centimeters squared. So whenever we have a scatter graph, chances are we'll be drawing a line of best fit. And so that's what we'll start off with, draw a line of best fit in. And it says we're looking for a height of the box, or an estimate of the height of the box with the width of 17. So 17 is here. So the width of 17 will be a line across, let's try and get this just right, line across there. And what we do is we draw a line down when it hits the line of best fit. Now looking at the scale here, this seems to be going up in 2s. And so this line here would be at 3. To find the surface area of the cuboid, I'm just going to label the faces and do them individually. So we've got A, which is 24 by 13. So we're going to do 24 times 13, which is 312. Next we're going to do B, which is this one at the top, and it's 24 across and 8 is the length. So 24 times 8, which is 192. And finally C on this side here, which is going to be 13 times 8, which is 104. Now notice that the faces all have the exact same face on the opposite side. So this one at the back is also A, this one at the side is also C, and the one at the bottom is also B. So what I'm going to do is add up all the areas of the squares and double it. So to work out the surface area, we're going to do 2 times and then 312 plus 192 plus 104, and that will give me 1,216 centimeters squared, because it's an area. With these questions, we've just got to go around and fill in what we can, and there's going to be some numbers like this one here we can't fill in yet, so we're going to have to be strategic in the order we do it. I'm going to first of all look here and notice that the total of girls and boys is 29, the total of the boys is 18, so take away the 18 from 29 and we get 11. Next one I'm going to fill out is this one. Notice that the total for the green is 15, total for the boys who's picked green is 12, and therefore for the girls it's going to be 3. Then looking around, what's the next thing that we can fill out? We can fill out this one, because the total for the boys is 18, green is 12, blue is 1, therefore we've got 5 left over. Then we can fill out this one, 2 plus 5 is 7. Then we can fill out this one, so 2 plus 3 is 5, then plus another 6 would be 11, and then 6 plus 1 is 7. This question seems a lot harder than it is. What I'm going to do is I'm going to start by rewriting the prime factors, but without the squared, so 2 times 3 times 3 times 5 times 5. I'm going to do the same with the other lists as well, so 2 times 2 times 3 times 11. Now I'm going to put these into a Venn diagram, and so I'm just going to draw out a Venn diagram and get my 2 circles, because we're going to have the 450 and the 132. So 450 is on the left hand side and 132 is on the right hand side, and we're going to start just filling out the Venn diagram. So they both have a 2 in them and they both have a 3, but 450 has a 3, a 5 and a 5, and 132 has that 2 and the 11. Now to find the lowest common multiple, what you do is you just multiply all these numbers together, and that will give you the lowest common multiple. So what we're going to do is we're going to do 3 times 5 times 5, which are the numbers on the left, times 2 times 3, which are the numbers in the middle, times 2 times 11. And when we do that, we get 9,900, and that's it. So our answer is 9,900. So we're going to start just by writing this out. So m equals 7 brackets x minus 10. And we're going to put our solving lines in. I'm going to start by expanding the brackets. And we don't need to. We could divide both sides by 7, but I think this is a bit easier. And we're going to subtract, or we're going to add 70 to both sides. So we're trying to get x as the subject. So we're trying to get x on its own. And we're next going to divide both sides by 7. So we have m plus 70, all of that over 7 equals x. So x equals m plus 70 over 7. To find the density of this wooden block, we're going to have to first of all find out what the volume of the block is. And volume is the cross-sectional area times by the length. And the reason why it's that is it's a prism, and all prisms you just find the area of the cross-section and we times it by the length. So what is the shape of the cross-section? Well, the cross-section is a triangle, and the cross-section is this part here. I just quickly colour it in. And so we're just finding the area of that triangle, so half base times height. And we're going to times it by the length, and the length is how 3D the prism is. So the base is 3, the height is 14, and the length is 5, and when you do that you get 105 centimeters cubed. Right, now we need to find out what the density is, and the formula for density is mass divided by volume. The mass is given to us in the question is 246. The volume we've just worked out, is 105. And so you do 246 divided by 105, and you get 2.342 blah blah blah. And then we round that to 2 decimal places, which it says in the question to do, and that would be 2.34 grams per centimeters cubed. The first thing we need to do is work out the area of the floor, and you'll notice that this is a trapezium. So with a trapezium, the formula is half a plus b times h, and a and b are the parallel sides, so these ones are the parallel sides, and the height is the one connecting the two bases, the two parallel sides. So we're going to start off by writing down the formula, so it'd be half a plus b h, so half times 2.8 plus 1.2 times 11. And when we do that, we get 22. So the area of the floor is 22 meters squared. And it says here that the tiles are sold in packs which cover 3 meters squared. So if each pack covers 3 meters squared, we're going to do 22 divided by 3, which will be 7.33 packs that we need. Now obviously you can't get 0.3 of a pack or 0.33 of a pack, so we're going to have to get 8 packs and just have some left over. So we'll need 8 packs in total. Okay, the next thing we look at is the fact that the Jenny has a 25% discount. So we need to find out what 25% discount would do to the £18.60 for the tiles, or for the pack of tiles. And so what we're going to do is we're going to get the £18.60 and we're going to times it by 0.75. So we're just going to find 3/4 of it because she has a 25% discount, and that would be 1,395. So that's the tiles are going to cost £13.95. Now I've done this in pence and I've kind of muddled it together here, so really let's just go back because I've kind of done this in pence. So that would be 1,860 times 0.75, and so each pack will cost 1,395, and the reason we're doing this in pence is the answer needs to be given in pence, so I might as well just make that conversion now. And so it's going to be 8 lots of the 1,395 pence packs, which will cost in total 11,160 pence, or £111.60. But Jenny has £100 to spend, and we're asked how much extra does she need. So we're going to do the 11,160, take away the 10,000 pence that she has, which will give us 1,160 pence. So she needs to find £11.60 or 1,160 pence from somewhere. So the symbol here basically means and the way I remember it is if you draw that symbol and just put a line through it, you can make the word and. So we're looking at the probability of getting something that is in A and C. So the only ones that are in A and C are this 8 and this 9 here. So we're going to just add the 8 and the 9 together, which give us 17. Now we need to then work out how many numbers there are in total, so that's all of them. So 4 plus 8 plus 9 plus 5 plus 8 plus 3 plus 11 plus 6. So we need the total, which is 54. And then we get the 17, and we put that over the amount in total, so over 54. To find the largest weight this package could have been before it was rounded, let's do a quick number line, and we're going to just do it between the 24 and what it would round to next. Well, it's 10 to the nearest kilogram, so the next thing it would round to is 25. The cutoff point for rounding is here. And that's going to be halfway between 24 and 25, which is 24.5. And that is actually going to be our answer. Now, some of you who are astute might realise that 24.5 would round to 25, but theoretically the biggest it can be is going to be 24.49 recurring. Let's just draw that a bit better, 24.49 recurring. And that is actually the same as 24.5. In your exam, however, you can write 24.49 recurring and you would get full marks, but for brevity, I would definitely recommend writing 24.5. So to find the gradient, we need the formula or the equation in the form y equals mx plus c, and the m there will give us what the gradient is. So we're just going to be rearranging this equation. And so I'll get my lines in. So the first thing I'm going to do is get rid of the x's from the left hand side, and we can do that by adding 6x both sides. So we've got 6y equals, and I'm going to put the 6x first just to match the y equals mx plus c. Right, the next thing I'm going to do is get rid of this 6 because we just want a y there. So we're going to divide by 6 both sides. So we've got y equals 1x plus 36. Now we shouldn't really write 1, but because we're looking for m, we're looking for the number before x, I've kind of left it in there to show that the gradient will be 1. So we're asked to reflect this shape along the line y equals x, and y equals x is a diagonal line where all the x values are equal to the y values. So at the bottom here we've got x is 10 and y is 10, so that coordinate would be 10, 10. And then obviously this coordinate 4, 4, etc. So we need to reflect it across this line. And so if I pick a point, I'm going to pick the top one. We can see it goes 4 diagonals to hit that line. So 1, 2, 3, 4. So it will go another 4 diagonals. So that will be one of the coordinates there. And I'm going to do the same with the bottom one. So 1, 2, 3, 4, 5, 6 diagonals. 1, 2, 3, 4, 5, 6 diagonals. So it will be there. And then finally, I'm going to do this slightly harder one. So we've got 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Kind of goes over the other one, ends up here. So if we join these up, and we need to label it B. We can't work out what x is straight away, but we can find this value here. And we know with Pythagoras we can find a third length if we've got other two in a right angle triangle. So a squared plus b squared equals c squared. And a and b were labelled. C is always opposite the right angle, so it'd be 49 squared plus b squared equals 68 squared. And 49 squared is 2,401. And 68 squared is 4,624. So we are solving here, so let's get our lines down. And we're going to start by subtracting the 2,401 from both sides. So we've got b squared equals 2,223. Then we're going to square root both sides, and we've got b equal to 47.148, blah blah blah. Okay, we're now looking at the second diagram, and this time we're going to have A, we've got our B, and we're going to call X the C. So it'd be A squared plus B squared equals c squared, but this time a is 39. B we are given as 47.148. We've just worked that out. And we're looking for c. In fact, we can call it x now. Okay, so we need to square that. So we do 39 squared plus 47.148 squared, and that will be 3,744 equal to x squared. And we'll just get our lines in because we need to square root both sides, and we get 61.188 blah 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 is equal to x. It says it wants it to 2 decimal places, so that would be 61.19. To find the median, we need to have all the numbers in a list from smallest to biggest and find the middle num. Now, we can't do that when we're using a table like this, or it's not very practical to. So we need a kind of different strategy, and the way we do it is to use a simple formula to find the position of the median. Now, the median will always be in the n plus 1 divided by 2 position. So we need to find out what n is, and we do that by adding up all the frequencies there. So let's add those together, and you get the sum of f. So those add up to 15. So if you do 3 plus 4 plus 2 plus 1 plus 5, you get 15. And so we've got 15 plus 1 divided by 2. 15 plus 1 is 16, divided by 2 is 8. So the position of the median is in the 8th position. Now, to easily find out which group, because it's asking for the class interval, which is just a fancy way of saying a group, so it could be this one, or it could be this one. To easily find out which group the median is in, what we do is a quick running total. So what I'm going to do is add up the frequencies as I go along. So we've got 3 there, 3 plus 4 is 7, plus 2 is 9, plus 1 is 10, plus 5 is 15. And then what I do is just convert those into 3rd, 7th, 9th, 10th, and 15th. So what those numbers are the last time that a number is in that group. So we've got 3 numbers that are in the group 10 to 25, and the third one is the last number in that group. The fourth one, therefore, will be in the 25 to 40 group. So we're looking for the 8th one. Well, the 7th one is the last one in this group. So the 8th one will be in this group here, as well as the 9th. Then the 10th one will be in the next group. So when it asks for a class interval, all we need to do is copy down exactly what the group is. So it's 40 to 55. And don't ever write down 40 to 55 or anything like that. Always copy it exactly from the table. When factorising quadratic, and this is a quadratic, so we've got an x squared term, an x term, and a number term, what we need to do is we need to find numbers to put in 2 pairs of brackets. And to do that, we first of all look at the number on its own, the 28, and the 2 numbers, we need to find 2 numbers that multiply together to make that 28. We also look at that minus 16, the coefficient of the x term, and we know that they've got to add together to make that minus 16. So something you can do is just quickly write down the factors of 28, and so that's going to be 1 and 28, 2 and 14, 4 and 7. Now, they can actually both be negative as well. So minus 1 and minus 28 is still multiplied together to make 28. Minus 2 and minus 14. And minus 4 and minus 7. But they need to add together to make 16. So we're going to check these to see which add together to make 16. So looking down the list, it's going to be these 2 here. Minus 2 plus minus 14 is minus 16. The first terms in our brackets are both going to be x, and we're just going to put the minus 2 in one of the brackets and the minus 14 in the other. What I'm going to start off by doing is rearranging this equation so that it kind of matches this one. So I'm just going to write it down. And we want the n to be -2. So what I'm going to do is I'm just going to put my rearranging lines in, and we're just going to add 10 to both sides. Now, we've already got this line drawn for us on this graph. And so all we need to do is draw this line. So we've got y equals 10x squared plus 8x minus 2 drawn for us. We just need to draw this line, which is y equals 10, and see where they cross over to find the solutions. So y equals 10 will be all the way up at the top. Let's just make sure I get it nice. There we are. I need to move that up a little bit. There we are. And let's read off the values that that gives us. So it comes down here, and it comes down here. So the values it comes down to are minus 1.6 and 0.8. And those are our solutions. Factorising is the opposite of expanding. So instead of removing things from a bracket, we're actually putting them in a bracket. And so we're going to start off by just putting the bracket down. And we're going to think, well, what can we put on the outside? So we look at the 20x squared and the 35x. And we first of all think of the number. So we're looking for the biggest number that goes into 20 and 35. Essentially, its highest common factor. Well, that's going to be 5. And then we look at the letters. So we look at the most amount of letters we can divide out. Well, this only has an x here, so it's just going to be an x. Then what we're going to need to ask ourselves is 5x times what is 20x squared? Well, 5 times 4 is 20, and x times x is x squared. Then to get the second term in the bracket, we ask ourselves, what times 5 is 35? Well, that's going to be 7. And what times x is x? Well, we don't need an x on the end of that. 5x times 7 is 35x. And you can actually expand that, and you can use any method you want. I'll use smiles and rainbows. And so we're going to do 5x times 4x, which is 20x squared, and 5x times 7, which is 35x. So our answer will be 5x brackets 4x plus 7. So we know that the exterior angle is equal to 360 divided by the amount of sides, which we can just call n. And something you can do is actually just swap these two things around. And we can say that the n, the amount of sides, is 360 divided by the exterior angle for a regular polygon. So we just do 360 divided by 5, and that gives us 72. The word truncated means that we just literally cut off the next number along. So if we imagine this is our number, we just cut it off. So it's not the same as rounding. We just don't change this digit at all. We just cut off the remaining digits. So the smallest number it could be before it was cut off is 79.500000. The largest number it could have been, well, it could have been 79.5999, etc. So that's the largest it could have been. So to do our error interval, well, the smallest it could have been is 79.5, and it could have been 79.5, and we'll call this x. But we're looking at any number that is less than 79.6. So any number that's less than 79.6. If it was 79.6, then when we cut it off, it would show as 79.6. So there are 3 parts that we need to find the area of. We're going to start with the easiest bit first, this circle at the bottom here. Okay, so the circle area is just going to be pi times r squared, and the radius is given to us at the top, which is 9, so it's just going to be pi times 9 squared, and that would be 254.469 blah blah blah. Well, we could leave it as 81 pi. Next bit is the curved bit of the cylinder. So we're going to do the cylinder next. And it's just the curved bit, and the formula for that is 2 pi r h. So 2 times pi times the radius, which is 9, times the height, which is 30, and that will give us 1696.460 blah blah blah. And the last bit is this hemisphere here, and so let's do the hemisphere. And the formula for the area of a hemisphere, well, this full sphere is 4 times pi times r squared, but because it's a hemisphere, it's half of that. And so it'd be half times 4 times pi times the 9 squared, and that will give us 508.938. And so the final thing is to work out the total area, so total surface area, and we're just going to add up all these numbers together. So we add up the 254.469, the 1696.460 blah blah blah, and the 508.938 blah 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 blah, and we get 2459.867 blah blah blah. Do make sure you show the examiner that you're adding these three here. I've not done that because it would waste a bit of time for a video, but make sure you write it down. It says it wants it to 2 decimal places, so that will be 2459.87 centimeters squared. There are a few different ways you could answer this question. I'm going to do it with a tree diagram, but you didn't need to draw a tree diagram to answer this question. So we've got our first tree, which is our first bus, and the choices are male and female. And we've got our second kind of branch, I suppose, and it's still male and female. And this is our second bus. So the property of male on a first bus is 9/15, and therefore the property of female is 1 minus 9/15, which would be 6/15. Male on the second bus is 7/15, and so female would be 8/15 because they need to add up to 1, and it's independent, so these will be the same. And the question is basically asking what is the probability that both will be female. So to have both female, we need to have gone down this line at the start and then this line again. Okay, so looking at the fractions along the way, it's 6/15 and 8/15. The word "and" in probability means times. So whenever you're finding the probability of getting to an outcome, so this outcome will be FF, because they're both female, you are multiplying the fractions that you go across. So it would be 6/15 times 8/15. So 6 times 8 is 48, and times the bottoms, 15 times 15 is 225. Now you can actually cancel that down. So what you can do is you can divide top and bottom by 4, and that will give you 16. Is it 4? No, you can divide top and bottom by 3, and that would be 16/75. So either 48/225 or 16/75. When drawing a quadratic or a cubic or reciprocal graph, you've got to make sure that you find as many coordinates as you can with curves. With a linear graph, the minimum you need is 2, and we normally take 3 coordinates. With a curve, we need loads. So I'm going to pick loads of x coordinates. So I'm just going to pick all of the integers. Lots and lots. And I'm going to find out what the y coordinate is. So for the first one, I'm going to put in, on my calculator, a quarter times brackets -4, close brackets, +4, and all of that in brackets. Then I'm going to do the second bracket. So I'm going to put bracket -4, close bracket, -1, close bracket. And then bracket -4, close bracket, take away 4, close bracket. Okay? So I'm just going to put in bracket -4 each time you see an x here. When you do that, you get the answer of 0, which makes sense because -4 plus 4 is 0, and whenever you times something by 0, it will get to 0. Then I'm going to do the same with -3, and I get 7. Same with -2, I get 9. Same with -1, I get 7.5. Same with 0, I get 4, and 0, then -3, then -3.5, and at 4 I get 0, then 9, and then 25. Now that last one, the 25, is not really that helpful because the axis only goes up to 16. So the next thing is I'm going to plot them. So -4 is at 0, so that'll be here. -3 is at 7, so that's going to be halfway here. Then we're at 9, which will be halfway here. 7.5 is a bit more interesting because it's halfway between 7 and 8. So it would be about here. Then 4. Then 0. So it looks like it's going to go down now, but it's going to go down for a little bit, like down here where it's -3, and even further down here where it's -3.5. But then it starts going up again. So 0, and then 9, and then we're off the top. So the next thing we need to do is join that. Now it's sometimes easier if you turn the page sideways. It depends on the curve. I can't turn this sideways, so mine's hopefully gonna look okay. And it's one continuous curve going through all the points. And so we're going to try our best here. And it's not easy for me because I can't quite see the points. You shouldn't take your pencil off at all. Just I have to because my hand gets in the way. And then we know it shoots up from here. Now, that doesn't look the best curve in the world, but as an examiner, what am I looking at? I'm looking at the fact that it goes through all the points, which it does. I'm looking at the fact that there's no obvious gaps, which there isn't. It stops here, but it goes off the top of the graph here, so that's fine. I'm looking for no feathering, which is where you do kind of that with the pencil. No. There's no feathering there. There's a little bit of a wavy bit there, but I think a lot of students get worried that they're going to lose marks unless it's perfect and they start rubbing it out. Like if you've missed a coordinate and you've kind of gone around something, then yeah, maybe rub it out. Or if you've got feathering, or if it just goes, if you knock your hand and it goes off or whatever. But unless it's awful, unless it's not going to get the marks, just leave it. If it's a bit wavy, if it's a bit weird round here, and I think, you know, it's not perfect around this bit either, don't worry about it, leave it, it'll still get the marks. Yes, this one doesn't quite go through the coordinate, but it's close enough. And, you know, I think that students often, when I'm marking, I see that they've rubbed it out several times, and where I can see it still there, it was fine. It was going to get the marks regardless. And so it's wasted time, and it just makes it look a bit messier. So it doesn't have to be perfect. So we need to first of all work out what the length of the side of the square is. And to do that, what we do is we get the 44v to the power 4 w to the power 5, and we just divide it by 4. And to do that, all we need to do is just divide the coefficient by 4. So it'd be 11v to the power 4 w to the power 5. Some people will try and do something with the v to the power 4 w to the power 5, but if you think about it, if I just draw out my square, if it's 11v to the power 4 w to the power 5 all the way around, when you add, you don't add the v to the power 4 w to the power 5. It's just going to be 11 lots, another 11 lot, another lot of 11, and another lot of 11. So it's 44 v to the power 4 w to the power 5 in total. And to work out what the area is, we obviously are going to square that. So we're going to do 11 v to the power 4 w to the power 5, and we're going to just times it by itself, which is what squaring means. Okay, so we're going to times the 11s together, so that's going to be 121. Going to times the v to the power 4s together, and remember with indices, if you times two powers of the same base, and they're both v, then we just add the powers together, so that'd be 8. And we're going to add the w to the power 5s together, so that makes 10. So it's 121 v to the power of 8, w to the power of 10. So we're asked to find the vector 3a plus 2b. So we're going to start off by working out 3a. And so we just go times the top and bottom of a by 3. So that'd be 9 and 6. And to find 2b, we do exactly the same to the second one, but we're going to times it by 2. That'd be minus 2 and minus 4. And so to find 3a plus 2b, we're just going to add the tops together. So 9 plus minus 2. And add the bottoms together, so 6 plus minus 4. 9 plus minus 2 is 9 take away 2, which is 7. And 9 plus minus 4 is going to be 2. So the vector is going to be 7 and 2. You can complete a unique version of this paper by going to our onmaths site. onmaths is full of free content to help you prepare for your exams, such as topic-based papers, demon questions, and mini mocks. If you like what we do, please consider subscribing.